The world that broke the solar system? In August 2006, a room full of astronomers did something extraordinary. They voted to erase a planet from existence. Not by destroying it, but by changing what the word planet means. The decision split the scientific world in half. Colleagues who had worked together for decades stopped speaking. Academic papers turned into battlegrounds. And at the center of it all was a frozen world so distant that light from the sun takes more than 13 hours to reach it. This is the story of Eris, the cosmic troublemaker that forced us to reimagine everything we thought we knew. A conflict 70 years in the making. For most of the 20th century, our solar system felt complete. 9 worlds circling a single star. A tidy arrangement that children memorized in school. But something was wrong with this picture. Deep in the astronomical archives, hiding in plain sight, were clues that our map was incomplete. Tiny points of light drifting almost imperceptibly across forgotten photographs. Objects that moved too slowly to attract attention. Too faint to seem important. Until someone looked closer, the hunt beyond Neptune. At California's Palomar Observatory, 3 astronomers were conducting an unusual survey. Mike Brown, Chad Trujillo, and David Rabinowitz weren't looking for anything in particular. They were systematically photographing vast sections of the night sky, searching for anything that moved. Anything that didn't belong to the realm of fixed stars. Their telescope captured wide fields of view. Automated software flagged objects moving at specific speeds, objects that might be orbiting in the frozen darkness beyond Neptune. And they were finding things, strange worlds with names like Quaoar, Orcus, and Sedna. But Mike Brown wanted something bigger. Something that would change everything. As he later wrote in his notes, the idea that the 9th planet was alone out there seemed absurd. If one world could exist in that region, there had to be others. Perhaps even a 10th planet, the Discovery. Months passed as Brown began manually reviewing old data that the software had dismissed. Then, on January 5th, 2005, late at night, clicking through image sequences from more than a year earlier, he saw it. 3 photographs taken on October 21st, 2003. A single dot of light, moving. But this dot was different. It was bright, brighter than anything they'd found before. And it was moving incredibly slowly, which meant only one thing. It was unimaginably far away. Brown's first thought wasn't scientific. It wasn't cautious. It was simple. I found a planet. The team began tracking the object, giving it a temporary designation of 2003 UB 313. They calculated its orbit, estimated its size, and decided to keep quiet until they knew more. But the world of planetary science is competitive. Ruthlessly so, the forced announcement. In July 2005, another research team announced the discovery of a large world called Haumea. But there was controversy. Evidence suggested this team had accessed Brown's public observation logs, had seen what Brown's team was tracking, and rushed to publish first. Brown faced a choice: stay quiet and risk losing credit for everything, or go public immediately. On July 29th, his team made their announcement. Not one major discovery, but 2. Haumea, and this other object. This thing that would eventually be called Eris. The impossible problem. Initial measurements created an immediate crisis. Eris appeared to be larger than the 9th planet, and more massive than the 9th planet. If the 9th planet was truly a planet, then this new world certainly had to be one too. But if this was a planet, what about all the other large objects they'd been finding? Makemake, Sedna, dozens of icy worlds scattered beyond Neptune. Where would the line be drawn? The problem was elegant in its simplicity. Either the solar system had dozens of planets, or it had fewer than 9. There was no middle ground. The Battle of Prague. In August 2006, Prague, Czech Republic hosted the International Astronomical Union's General Assembly. For the first time in history, they would formally debate what the word planet actually means. The assembly lasted 10 days. 2,500 astronomers attended, and the debates grew heated. Two camps emerged with two completely different philosophies. The first group believed in intrinsic properties. If an object is massive enough for gravity to pull it into a sphere, it should be called a planet. Simple, clean, based on what an object is. Under this definition, dozens of worlds would qualify, including Eris, the 9th planet, and even Ceres, the largest asteroid. The second group believed in context, in relationships, in gravitational dominance. A planet, they argued, isn't just about what you are. It's about what you do. A true planet must be the dominant gravitational force in its orbital zone. It must have cleared its neighborhood of other objects. It must rule alone. The final vote was scheduled for the last day, but there was a problem. Most attendees had already left. Conference sessions were over. People had flights to catch, jobs to return to. Of the 2,500 astronomers who came to Prague, only 424 remained to vote, less than 1/5 of those present, a tiny fraction of the global astronomical community. The votes were counted. The dynamical definition had won. The new rules were clear. A planet must orbit the sun, must be massive enough to be spherical, and must have cleared its orbital neighborhood. The 9th planet met the first two criteria, but it shared its orbital space with Neptune's influence and thousands of other icy objects. It failed the third test. A new category was created, Dwarf planet. And crucially, a dwarf planet was not a type of planet. It was something else entirely. In one vote, the solar system went from 9 planets to 8. The naming, the team had earned the right to name their discovery. Mike Brown chose carefully. In Greek mythology, Eris was the goddess of strife, of conflict, of discord. When she was excluded from a wedding celebration, she threw a golden apple among the guests, inscribed with the words, "For the fairest." The resulting quarrel led directly to the Trojan War. The name was perfect. This distant world had thrown a golden apple into the halls of astronomy, had started a war over the meaning of a fundamental word, had forced scientists to choose sides. In September 2006, the name was officially accepted. The Outcast's domain, now that we understand what Eris did to our solar system, let's travel there to understand the world itself. Eris doesn't orbit in the Kuiper Belt, that relatively stable disk where the former 9th planet resides. It lives somewhere wilder, a region called the scattered disk. The scattered disk is chaos given form, a vast halo of icy bodies with extreme orbits. These are the solar system's exiles, objects that likely formed closer to the sun, but were gravitationally flung into the darkness by Neptune billions of years ago. Eris takes 557 Earth years to complete one orbit. At its closest approach, it comes within 38 astronomical units of the sun, about the same distance as the former 9th planet's average orbit. But at its farthest point, Eris swings out to nearly 98 astronomical units, almost 15 billion kilometers away, 3 times farther than the 9th planet's current position. And its orbit is tilted 44 degrees to the plane where the major planets travel. For more than half its year, Eris soars high above the solar system, or plunges far below it, a lonely traveler in the cosmic dark. The dense twin. For years, astronomers assumed Eris was larger than the 9th planet. Then, in 2010, they had an opportunity. Eris passed directly in front of a distant star. By timing how long the star's light was blocked, from different locations on Earth, they could measure its size with extraordinary precision. The result was unexpected. Eris has a diameter of 2,326 kilometers, almost exactly the same size as the former ninth planet. In fact, slightly smaller. But here's where it gets interesting. Eris is 27% more massive despite being smaller, which means it must be significantly denser. Scientists calculated its density at 2.43 grams per cubic centimeter, while the ninth planet's density is only 1.85. This reveals something fundamental about Eris' structure. While the former ninth planet is roughly 70% rock and 30% ice, Eris must be predominantly rock. A rocky heart wrapped in a comparatively thin shell of ice. The brilliant surface, that icy shell is one of the most reflective surfaces in the known solar system. Eris has an albedo of 0.99, reflecting 99% of the sunlight that reaches it. This is extraordinary because almost nothing in nature is that reflective. The explanation lies in a process called atmospheric collapse. Like the ninth planet, Eris has an atmosphere, primarily composed of nitrogen and methane, that has turned from ice to gas. As Eris travels on its extreme orbit, carrying it into the deep freeze of its farthest point, this atmosphere freezes solid and falls to the surface as fresh, bright frost like snow. As Eris begins its 280-year journey back toward the sun, this frost warms and sublimates back into gas, renewing the atmosphere, only to freeze and fall again centuries later. A perpetual cycle of breath and ice, ice and breath. Recent observations from the James Webb Space Telescope revealed something else. Different isotopes of methane on Eris' surface appear to have been produced by geothermal activity. This distant, frozen world may have a warm interior, or at least it once did. The dark moon. In September 2005, using advanced adaptive optics technology, Mike Brown's team spotted something orbiting Eris, a moon. This changed everything. While an object's size can be estimated from its brightness, its mass can only be determined with certainty by observing its gravitational effect on another body. By tracking the moon's nearly circular, 16-day orbit, they could calculate Eris' mass with precision. This definitively proved Eris was more massive than the ninth planet, making the planet debate not just academic, but urgent. The moon itself is fascinating. It's one of the largest moons of any dwarf planet, second only to Charon, and larger than Saturn's moons, Enceladus or Mimas. But while Eris is brilliant white, its moon is incredibly dark, darker than coal. The leading explanation is a violent birth. Early in the solar system's history, a massive object likely slammed into young Eris, blasting debris into orbit. This debris eventually coalesced into a single satellite. The impact would have stripped away volatile ices, leaving behind a darker, rockier body. Just as Eris was named for the goddess of discord, her moon was given the name of her mythological daughter, Dysnomia, the daemon spirit of lawlessness. The true legacy. Mike Brown earned a nickname after 2006, the Pluto Killer. But this misses the point entirely. Finding Eris didn't kill the ninth planet. It revealed its true family. It made our solar system larger, more complex, more interesting. For decades, we had a flawed model. 8 planets of a certain character, and then one strange outlier that didn't fit the pattern. By forcing this reclassification, Eris gave us a more accurate picture of our cosmic home. There are 4 inner rocky terrestrial planets, 4 gas and ice giants. And beyond them, a vast third realm, a swarm of thousands of icy dwarf planets, a population of worlds whose existence we were only beginning to grasp. Eris and the former ninth planet are monarchs of this third zone, the largest and most prominent members discovered so far. The final mystery. And Eris remains the ultimate mystery. It is the most massive known object in our solar system that has not yet been visited by a spacecraft. While NASA's New Horizons mission gave us breathtaking images of the former ninth planet, Eris remains a distant point of light, its secrets held across billions of kilometers of empty space. A proposed flyby mission would take an estimated 25 years just to arrive, a journey that would span generations. For the foreseeable future, the goddess of discord will keep her secrets. The story of Eris teaches us something profound about scientific truth. Sometimes the most important discoveries aren't the ones that provide final answers. They're the ones that force us to ask better questions. The debate over what makes a planet wasn't resolved in Prague, not really. Many astronomers still disagree with the 2006 decision. New proposals emerge regularly, and the conversation continues. Perhaps that's exactly as it should be. Science isn't about achieving perfect, unchanging truth. It's about refining our understanding, adapting our models as new evidence emerges, being willing to change our minds. Eris forced us to confront our assumptions, to recognize that our neat 9-planet solar system was an artifact of incomplete knowledge, not fundamental cosmic law. In doing so, it revealed a solar system far richer and stranger than we imagined. And out there, in the frozen darkness, countless other worlds await discovery, each one carrying the potential to overturn what we think we know, to reveal new patterns, new mysteries. The goddess of discord threw her golden apple, and we're still picking up the pieces. Still arguing over what they mean, still exploring. If this journey to the edge of the solar system fascinated you, there's so much more to explore. Consider subscribing to follow future expeditions into the cosmic unknown. Do you think the 2006 decision was correct? Should we have dozens of planets instead of 8? Or does the current system make more sense? Share your thoughts with us. The debate that Eris started continues with you. Thank you for watching. And remember, in the darkness beyond Neptune, the strangest discoveries are still waiting to be found.